Hello everyone! This presentation covers the findings of our ECG565 group project. Our team Mohammed Hazek, Mohammed Adil Azim, Mohammed Alif Jakwan, and Mohammed Iqbal has conducted a series of field tests to evaluate pavement surface characteristics. To measure the pavement macro texture, we follow the sand patch method. First, we ensure the test surface is dry and swept clean of any debris. Next, we fill a standardized cylinder with a known volume of sand, in our case, 20,000 mm 3. We pour the sand onto the surface and use a flat spreading tool to carefully spread it into a circular patch, ensuring the sand fills all the surface voids. Finally, we measure the diameter of the sand patch for different angles to calculate the average diameter. This average is then used in the formula for volts, high dA, to determine the texture depth. First, we conducted the sand patch test to determine the texture depth of two different locations. Using a fixed sand volume of 20,000 mm 3, we measured the diameter of the spread. At location A, the average diameter was 170 mm, resulting in a texture depth of 0.88 mm. This characterizes it as a rough surface. At location B, the sand spread wider to an average of 177 mm, giving us a lower texture depth of 0.81 mm, which indicates a smoother surface. Next, to evaluate the friction of the car park surface, we use the skid resistance test. Before beginning, we calibrate the pendulum to ensure it swings freely and zeroes out correctly. For the dry test, we release the pendulum arm from a horizontal position, allowing the rubber slider to strike the pavement surface. We record the skid resistance value, or SRV, shown on the scale. We repeat this at least 3 times to get a consistent average. wet test, we thoroughly wet the pavement surface with water and repeat the swinging process. This allows us to compare how much grip is lost when the road is rainy or damp. Next, we assess the safety of a car park by measuring its skid resistance value, or SRV. This test helps us understand how well a vehicle can grip the road surface. Under dry conditions, the surface performed exceptionally well with an average SRV of 118.67. When we tested the same area under wet conditions, the resistance naturally dropped. But it maintained a strong average SRV of 114.67. These high values suggest the car park surface provides excellent traction. The final test is the outflow meter test, which measures how quickly water can escape through the pavement texture. We place the outflow meter cylinder onto the surface and ensure a watertight seal at the base. We then fill the meter with a standard volume of 400 milliliters of water. The valve is opened, and we start a stopwatch immediately. We record the time it takes for the water level to drop between two marked points in the cylinder. A faster time, as seen at location A, indicates a rougher surface with better drainage properties. We perform the outflow meter test to observe how quickly water drains through the surface texture. We used a standard water volume of 400 ml. Consistent with our sand patch results, location of the rougher surface allowed water to flow out in just 8.49 seconds, with a flow rate of 4.71 times 10 to 5 MA. Location B, being smoother, was slightly slower, taking 9.1 seconds with a flow rate of 4.39 times 10 to 5 MA. This confirms that surface roughness directly improves water drainage. In conclusion, our tests show that surface texture significantly impacts both skid resistance and water drainage. These factors are critical for maintaining road safety and performance. Thank you for watching.